Right now, at this very moment, an asteroid is heading toward Earth. Not a small one, not a pebble. A chunk of rock and ice kilometers across, moving at 60 kilometers per second, carrying enough kinetic energy to erase a city. An extinction-level impact, a civilization ender. It's hurtling through space toward our planet. And you don't need to worry, because Jupiter's is going to kill it before it gets here. You've never heard about this asteroid. It didn't make the news. NASA didn't issue a warning. Scientists didn't scramble. Because the asteroid isn't actually aimed at Earth. It's aimed at a slightly different trajectory. And Jupiter, massive, invisible, acting from 100 times farther away than Earth from the Sun, is going to pull it aside with gravity. The asteroid will miss us. It will fall into Jupiter's atmosphere. It will burn up. It will become nothing. And you'll never know it happened. This isn't speculation. This isn't rare. This happens constantly. Dozens of times per year, maybe hundreds. Asteroids that would have hit Earth, that would have caused regional devastation or extinction-level impacts, are diverted by Jupiter's gravity. Jupiter, it's saving us. Constantly. Without pause. Without recognition. Jupiter is the reason we're alive. And we barely understand how completely dependent we are on it. Let me show you what Jupiter is actually doing. The asteroid belt, the region between Mars and Jupiter, filled with millions of rocky bodies, is supposed to be there. It's a remnant of planetary formation. When the solar system was young, that region was filled with planetesimals, small bodies that should have coalesced into a planet, but Jupiter prevented it. Jupiter's gravity stirred up the asteroid belt. It increased the velocities of the bodies. The bodies collided. Instead of sticking together and forming a planet, they shattered. And the asteroid belt remained fragmented, chaotic, a region of scattered debris instead of a cohesive world. Jupiter did this intentionally, not intentionally in a conscious way, but as a natural consequence of its presence. Jupiter's gravity prevented planet formation in the asteroid belt. And because the asteroid belt never formed into a single planet, it remains dangerous, unstable, prone to perturbations. But here's where it gets fascinating. The asteroid belt isn't uniformly distributed. There are gaps, regions where asteroids are almost completely absent. We call them Kirkwood gaps, and they exist because of Jupiter. When an asteroid orbits at just the right distance from the Sun, its orbital period becomes synchronized with Jupiter's orbital period. Every time the asteroid completes an orbit, Jupiter pulls on it. The asteroid experiences gravitational impulses at the same point in its orbit, over and over. And those impulses accumulate. The asteroid gets knocked out of its original orbit. It either spirals inward toward the inner solar system or it gets ejected outward. The Kirkwood gaps are regions where this resonance is particularly strong. Asteroids that orbit at those distances get perturbed out almost completely. The gaps are cleaned out. They're empty because Jupiter is constantly clearing them. And here's the crucial part. Many of those cleared asteroids fall inward. They spiral toward the inner solar system. They pass through Earth's orbit. But most of them hit Jupiter first. Jupiter is positioned like a cosmic goalie. It's downwind of the asteroid belt. Asteroids that get perturbed inward are more likely to encounter Jupiter than Earth. Jupiter's massive gravity reaches out and catches them. And because Jupiter is so massive, because its gravity is so strong, it deflects most of them. The asteroids fall into Jupiter's atmosphere. They burn up. They disappear. Jupiter is an asteroid trap, a vacuum cleaner, a protective shield made of gas and gravity. Without Jupiter, Most of those asteroids would continue into the inner solar system. Many would hit Earth. We'd be experiencing impact events constantly. Regular extinction-level catastrophes. Civilization couldn't develop. Complex life might not even exist. But Jupiter is there. Jupiter is catching the asteroids. Jupiter is protecting us. But here's what makes this even more crucial. The late heavy bombardment, a period about 4 billion years ago when the solar system was flooded with asteroids, might have been caused by Jupiter's migration. When the solar system was young, Jupiter didn't orbit where it is now. Jupiter was closer to the Sun. And then, through gravitational interactions with the protoplanetary disk, Jupiter migrated outward. That migration created chaos. It destabilized the asteroid belt, it destabilized the outer planets, and it sent a flood of asteroids into the inner solar system. For several hundred million years, Earth was bombarded. Thousands of impacts, hundreds of extinction-level impacts. The entire planet was battered. Life barely survived. Most species were wiped out repeatedly, but eventually the bombardment ended. The asteroids were cleared, the solar system stabilized, and Jupiter settled into its current orbit. And in that stability, life thrived. Civilization became possible. Which means Jupiter, through its migration, through its gravity, through its presence, created the conditions for our existence. Jupiter destabilized the solar system enough to create chaos, but then stabilized it enough for life to evolve. Jupiter is a cosmic gardener. It's violent and chaotic, but it's also protective. But here's the terrifying part. Jupiter's position is precarious. The current configuration of the solar system, with Earth at the right distance from the Sun, with Mars and Venus and Mercury in their current orbits, with Jupiter positioned as a protective shield, this configuration is not inevitable. It's not guaranteed. It's contingent. If Jupiter were slightly closer to the Sun, its gravity would be stronger. More asteroids would be diverted. But the dynamics would change. Jupiter might perturb Earth's orbit. Earth might spiral toward the Sun or away from it. The habitable zone is narrow. A small change in Earth's orbit could make the planet uninhabitable. If Jupiter were slightly farther from the Sun, fewer asteroids would be diverted. More would hit Earth. The bombardment would be constant. Civilization couldn't develop. If Jupiter were significantly larger, its gravity would be overwhelming. It might have ejected all the inner planets. We might not exist. If Jupiter were significantly smaller, it wouldn't be able to clear the asteroid belt. Impacts would be constant. We're in a narrow window, a specific configuration where Jupiter is massive enough to protect us, but not so massive that it kills us. Where Jupiter is positioned to divert most asteroids, but not all of them. Where the balance is perfect. And that balance is not guaranteed to last. Jupiter's orbit is slowly changing. The planet migrates. It always will. And if Jupiter ever migrates significantly, if its orbit ever shifts enough to change the dynamics, the protection could fail. We could suddenly be exposed to constant bombardment. But let me show you something even more disturbing. We're not just dependent on Jupiter in our solar system. We're dependent on Jupiter in ways that affect the entire galaxy. Jupiter's gravity extends far beyond its immediate orbit. Jupiter influences the orbits of comets. Comets in the Oort cloud, a hypothetical sphere of icy bodies surrounding the solar system. Those comets are occasionally perturbed inward by passing stars. And when they fall toward the Sun, they pass through Jupiter's sphere of influence. Jupiter's gravity diverts most of them, but not all. Some comets still reach the inner solar system. Some still hit Earth. Jupiter is catching comets too. Jupiter is protecting us from long-period impacts, not just short-period asteroid impacts. If Jupiter weren't there, If we were in a solar system without a massive gas giant, comets would reach Earth much more frequently. Extinction-level impacts would happen regularly, once every 100,000 years instead of once every 100 million years. Civilization couldn't survive that. We couldn't build stable societies. We couldn't develop technology. We'd be in constant crisis management. But Jupiter is there. So the impacts are rare enough that civilization has time to develop between catastrophes. We've been incredibly lucky, but luck can run out. Let me show you what other solar systems look like. Astronomers have discovered thousands of exoplanetary systems, and many of them don't have massive gas giants in Jupiter-like orbits. Instead, they have hot Jupiters, massive planets orbiting close to their stars. Or they have no giant planets at all, or they have giant planets in chaotic, unstable orbits. And in those systems, the inner planets experience constant bombardment. Asteroids are everywhere. Impact events are regular. The inner solar system is a war zone. Those systems could have life, but the life would be microbial, primitive, constantly being reset by impacts. No civilizations, no intelligence, no technology. We have those things because we have Jupiter. We have Jupiter because of cosmic luck. Astronomical probability determined a gas giant formed at just the right distance from the Sun. If those initial conditions had been slightly different, we might not have Jupiter. Or Jupiter might be in a different orbit and we would not be here. But Jupiter is here, and that is why we exist. However, Jupiter is not a permanent guardian. Jupiter's orbit is decaying and the planet is slowly migrating outward. In billions of years, Jupiter will be farther from the Sun and the dynamics will change. The asteroid belt will become less stable and more asteroids will slip through. More impacts will hit Earth as Jupiter migrates. Eventually, in perhaps 10 to 20 billion years, Jupiter might migrate far enough to stop protecting the inner solar system effectively. The inner planets will be exposed to the full bombardment of the asteroid belt. Impact events will increase and Earth will become hostile. But that is the very far future. Let me show you what is happening now. The solar system is currently in a stable configuration with Jupiter in the right place. Earth is in the habitable zone and the asteroid belt is relatively contained. Life is thriving on our planet right now. There is a phenomenon called the Nice model that suggests the solar system might not always be stable. The Nice model proposes that planets migrated significantly in the early history of the solar system. Jupiter moved inward and then outward, while Saturn, Uranus, and Neptune also migrated. During that flux, the solar system experienced what is called the Grand Tack, where Jupiter moved toward the Sun, then retreated. That movement created chaos and scattered asteroids while destabilizing planetary orbits. If the Nice model is correct, then that kind of migration is possible again. Not necessarily in our solar system, but the possibility exists according to mathematical models. We are in a window of stability, but windows close. Here is what should genuinely frighten you. We have no way to predict when the stability might fail. The equations governing planetary orbits are chaotic and small perturbations grow exponentially. A passing star could perturb Jupiter slightly, and that could cascade into major changes. A gravitational interaction with a rogue planet could destabilize the system. A large asteroid impact could change Earth's orbit slightly, which could change gravitational dynamics over time. We are living in a dynamical system, and dynamical systems are unpredictable on long time scales.